This is the two slides about heating and cooling. So it's sort of like form equals content here. The passive house strategy is that you have a super insulated box with really great windows, and therefore you don't really have to spend that much energy uh, heating and cooling. And so we're not going to spend too much energy thinking about heating and cooling right now. But the way that we have the system configured is that we're using a VRF system, which is a variable refrigerant flow technology. It's a split heat pump that is very popular in Asia. In Japan, it's 90% of the market. In Europe, it's emerging as like 80+% of the market. In China, it's 90+% of the market. It's relatively new to North America, and it is a very idiosyncratic system relative to what we would typically provide. The big difference between conventional HVAC equipment and this equipment is that rather than pushing water around the building, which is sort of like a water source heat pump, or having the vapor compression cycle happen within a single box, these units push refrigerant around the building, and it splits the vapor compression cycle between the indoor units, which we call evaporators, and the outdoor units, which we call condensers. We've zoned the system in this building. This is not exactly how it's going to be, but diagrammatically indicative of the fact that we have a north loop and a south loop. And the reason why we chose the VRF system is that passive houses in Europe have exterior shading. And shading is a big deal because it's the means by which you control your solar gain, which is what drives your cooling demand in the building. And typically passive houses are not super tall, and typically they're in Europe. And over there, they have motorized exterior shading systems that don't do glare reduction. They are actuated by interior temperature sensors so that they come down and mitigate solar heat gain, thereby reducing your air conditioning requirement. On this building, even though we've got thermally robust windows, we have fairly typical solar heat gain coming through the IGUs. So on one hand, we have a fairly decent sized cooling load. I mean, nowhere near typical, but fairly decent. Whereas we also have no heating load. So we needed a system that would perform well under highly variable conditions. And the magic of the VRF is that it's a variable refrigerant flow system with inverter-based scroll compressors and linear expansion valves that have a 2,000 to 1 turn-down ratio. So we're fairly confident that it'll be able to perform well at partly loaded conditions and full loaded air conditioning. I should mention Bureau Happold's our engineer, and Julie Janaski is in the audience, and she's been wonderful. They assure me that there will never be a heating load in this building. It's sort of counterintuitive, and even for a true believer like myself, to get my mind around the fact that even on a 0-degree day, we will not have to heat the building, is sort of profound and amazing and perplexing and challenging. But this building is extraordinarily dense. We finished, recently finished a building on 30th and 10th called the Abington, and that's a 30-something story building, 390,000 square feet. It's a third bigger than the building we're discussing, but it has 2/3 of the amount of bedrooms, because this building has like half of the apartments are studios. So we're gonna have 532 or 352 refrigerators going all the time. And refrigerators, I think all of those refrigerators are basically gonna be enough to heat the building. It's crazy. All right, so the VRF, because it's so variable, and sensitive. The idea is that it's sort of like driving on cruise control, and it pegs to exactly the set point that you want, rather than banging on and off the way traditional equipment would. This is the diagram of where the condensers reside in the building. It's in this seam. Originally, we thought that this would be a student lounge on every floor where people could like share ideas and get a great view of the city. But then we decided, actually, we should put we should put our condensers there and give them a great view of the city. And so it was just sort of like a happy accident that we already had this amazing sort of natural louver band going up and down the building. Nobody has this in North America. Every single tall building in Asia has this, pretty much, especially Japan, a total building-wide louver band.